This is a continuation of example 2. This time we're going to test the claim that the rate of fatality is higher for patients transported by helicopter by building an appropriate confidence interval. So just to remind us, P1 represents the fatality rate for those transported by helicopter, and P2 represents the fatality rate for those transported by ground. Okay, so the claim is that the fatality rate for those transported by helicopter, so P1, is greater than P2, and we said previously that that is the alternative hypothesis, and so the null hypothesis is that P1 equals P2, and I'm going to keep track here. This is the original claim, the alternative hypothesis, and then also because we have the greater than sign here, this means that we have a one tail, more specifically, right tail test. It's really important for you to know whether or not you have a one-tail test or a two-tail test, because that is going to determine what your confidence level is going to be for the confidence interval. So that's what we mean when we say appropriate. All right, what percent confidence level are you going to use? So here, because we have a right tail test, that means we have a one-tail test. The area in the tail region of your confidence interval, it has to match up with the area in the tail region when you did the hypothesis test, because that's the only way we're going to come up with the same conclusion. So recall from the previous video that we use a significance level of 0.01. Okay, so that's your alpha. And because this is a one-tail test, on the right tail here, that corresponds with a critical value of 2.33. So right here, 2.33 is the critical value, which separates the area on the right with an area of 0.01. So when you're building a confidence interval on the bell-shaped curve always has two tails. And so I'm going to also have to mark the left tail here. So that right there is negative 2.33 with the same area to match it up with the right tail. Okay. All right. So here, this means that anytime you have a one-tail test, whether it's left tail or right tail, your confidence level is always going to be 1 minus 2 times alpha, which is very different from when you have a two-tail test. Okay, when you have a two-tail test, it's just 1 minus alpha. But if you have a one-tail test, your confidence level is always going to be 1 minus 2 times alpha. So here, that means I'm going to take 1 and subtract 2 times 0.01, right? Which means that's 1 minus 0.02. So the appropriate confidence level, which is what is represented by the center of the distribution, so the area that I'm shading in blue, this is where we're going to find our confidence level. Okay, so that's 1 minus 0.02. That gives me 0.98. So this means I'm going to build a 98% confidence interval. So the appropriate confidence level is a 98%. This is the information that you'll need to put into your calculator. So using the calculator function here, I'm going to use 2 proportion z interval. Once you put in all the relevant information, the calculator is going to give you the following interval: 0.0126 up to 0.02. Now let's talk about how we interpret this result. What does this tell us? So I'm going to put this confidence interval on a number line where 0 is in the center, and then hopefully you can see that the lower confidence limit of 0.0126, and again, this is not drawn to scale here, but I just need to see where it falls on the number line, and 0.02. So I've got the lower limit and the upper limit for my confidence interval. Can you guys see that 0 is not included in this confidence interval? So this confidence interval tells us this. It says that we are 98% confident that the difference between P1 and P2, okay, lies somewhere between 0.0126 and 0.02. So notice that these values are all positive numbers. So these are all positive differences. So if the difference, right, between P1 and P2 is positive, right, this implies that P1 is greater than P2. okay? Because if I were to subtract them, P1 minus P2, we see that's greater than 0, and values greater than 0 are clearly positive. So this tells us that the difference cannot be 0 because we're 98% confident that it's going to be a positive value, which means not 0. And so because it's not 0, that means that, all right, P1 is probably not equal to P2. So this is why we are going to reject the null hypothesis. So in conclusion, you can write, and I'll squeeze at the bottom here, since the confidence interval, okay, does not contain 0, okay, this means we can reject the null hypothesis and say that there is sufficient evidence to support the claim that the fatality rate is higher for patients transported by helicopter. So I'm going to put ... here because you would just restate that and notice that that conclusion is the same conclusion that we made back when we used a hypothesis test to test this claim. Okay, I'll show you real quickly how to do all this on the calculator. So on the calculator, again, you're going to go to Stat, tab over to Test, choose option B, 2 proportion Z interval, put in all your relevant sample data, and then make sure you understand how to interpret this confidence interval. And I always tell students, check all this information to make sure that you typed everything into the calculator correctly.